Hello everyone. So in today's video, we are going to go over this paper, Social Bias Frames, Reasoning about Societal and Power Implications of Language by Saap et al. Alright, so the abstract. So a fair warning, this paper contains content that might be offensive or upsetting to some people or many people, to be honest. So some discretion is advised. So language has the power to reinforce stereotypes and project social biases onto others. At the core of this challenge is that it is rarely what is stated explicitly, but rather the implied meanings that frame people's judgment about others. So, uh, I guess this is something which we all personally know. So, I don't really need to explain this stuff. This is more intuitive for say compared to other tasks. So, for example, given a statement, we shouldn't lower our standards to hire more women. So, most listeners will infer the implication intended by the speaker that women candidates are less qualified, even though it is not mentioned explicitly in the sentence. Most semantic formalisms today do not capture such pragmatic implications in which people express social biases and power differentials in language. So, these are the main two challenges. So they introduce social bias frames, a new conceptual formalism that aims to model the pragmatic frames in which people project social biases and stereotypes onto others. So in addition, they introduce the social bias corpus to support large-scale modeling and evaluation with 150,000 structured annotations of social media posts covering over 34,000 implications about 1,000 demographic groups. So it's a very large data set, a very large when you compare it to say hate speech, typical hate speech datasets. And then they established the baseline approaches that learn to recover social bias frames from unstructured text. They find that while the state-of-the-art neural networks are effective at high-level categorization of whether a given statement projects unwanted social biases, they are not effective at spelling out the more detailed explanations in terms of social bias frames. So this study then motivates future work that combines both structured pragmatic inference and common sense reasoning on social implications. So I guess so far it's pretty clear what they're trying to do. So again, I'll be showing some examples which might be offensive. So please keep that in mind. Language are enormous power has enormous power to project social biases and reinforce stereotypes on people, and this way the way such biases are projected is rarely in what is stated explicitly, but in all the implied layers of meaning that frame and influence people's judgment about them. For example, on hearing a statement that an all Muslim movie was a box office bomb, most people can instantly recognize the implied demonizing stereotype that Muslims are terrorists. So understanding these biases with accurate underlying explanation is necessary for AI systems to adequately interact in the social world, and failure to do so can result in the deployment of harmful technologies such as conversational AI, which turned sexist and racist. So this was a chatbot deployed by Microsoft, which turned into this. So this is say, example sentence which we discussed. It's intentional, it's offensive, and but it's not lewd. Does it reference a group? Yes. And which group? So the Muslim community. And what's the implied statement? That it implies that all Muslims are terrorists. So most previous approaches to understand the implied harm in statements have cast this task as a simple toxicity classification task. So Wasim and Hovey, Fountain, Davidson, all of these are classic hate speech works. However, simple classification run the risk of discriminating against minority groups due to high variation and identity-based bias in annotation. So which cause models to learn associations between dialect and toxicity. So basically, there have been some works which have shown that models are more likely to flag African American English as toxic. In addition, detailed explanations are much more informative for people to understand the reason about why a why a statement is potentially harmful against other people. So they propose social bias frames, which is a novel conceptual formalism that aims to model pragmatic frames in which people project social biases and stereotypes on others. So compared to semantic frames, The meanings projected by pragmatic frames are richer and thus cannot be easily formalized using only categorical labels. That is why they have that fine-grained annotation. So they have multiple levels of annotation. One and some of them are hierarchical. So as illustrated in figure 1, our formalism combines hierarchical categories of biased implication, such as intent and offensiveness, with implicatures described in free-form text. So the annotators can fill in using the standard text. In addition, they introduce SBIC, which is the name of the dataset, a new corpus collected using a novel crowdsourcing framework. So SBIC supports large-scale learning and evaluation with over 150,000 structured posts and so on. We can also look at the other examples. So this is just one example. There's another example, which was discussed earlier. So it's we shouldn't lower our standards just to hire more women. Again, the intention is might be or might not be intentional. So it's slightly offensive, yes. Lewd, no, because it is not making a lewd remark. Is it referencing a group? Yes. And which group? The group of women. And what's the implied statement? It implies that women are less qualified. So then they establish baseline approaches that learn to recover social bias frames. Um, did we go with this? Oh, no. They find that while state-of-the-art neural networks are effective at making high-level categorizations, and say they get 80% F1 for those tasks of high-level categorization, but they are not effective at spelling out more detailed explanations by accurately decoding social bias frames. Our study motivates future research that combines structured pragmatic inference with common sense reasoning. So, some implications: we recognize that studying social bias frames necessarily requires us to confront online content that might be offensive or disturbing, and they have an ethical implication section. However, deliberate avoidance does not eliminate such problem, and this is exactly why more research is needed. Therefore, the important premise we take in this study is that assessing social media content through the lens of social bias frames is important for automatic flagging of AI augmented writing interface. For automatic flagging or AI augmented writing interfaces where potentially harmful content can be analyzed with detailed explanation for users and moderators. So moderators could just get a bunch of tweets which are on hold because they might have some bias or some hatefulness. In addition, the collective analysis over large corpora can also be insightful for educating people on reducing unconscious biases in their language. So you might just prompt the users that what you're saying might be biased. So now let's have a look at the proper definition of what or the definition which they've used. So to better enable models to account for socially biased implication of language, they designed a new pragmatic formalism that distinguishes several related but distinct inferences shown in figure 1. So given a natural language utterance, henceforth post, they collect both categorical as well as free text inferences, inspired by recent efforts in free text annotation of common sense knowledge and uh, argumentation. The free text explanation are crucial to the formalism as they can both increase trust in predictions made by the machine, so the machine can tell why it feels something, and encourage a poster's empathy towards a targeted group they were combating biases. We base our initial frame design on social science literature of pragmatics and impoliteness. We then refine the frame structure based on the annotator disagreement in multiple pilot studies, and now finally they have these variables. So first is offensiveness. This is the main categorical annotation and denotes the overall rudeness, disrespect, or toxicity of the post. We consider whether a post could be considered offensive to anyone, as a previous work has shown that this has shown this to have higher recall. This is a categorical variable with three possible answers: yes, maybe, or no. Then intent to offense captures whether the perceived motivation of the author was to offend, which is key to understanding how it is received. So a lot of times, even though a sentence might be offensive in itself, but the intention might not be to offend someone, so the implication or the result would not be anyone taking offense. This is again a categorical, so yes, probably, probably not, or no. Then you have lewd, or which has sexual references. So they are a key subcategory of what constitutes potentially offensive material in many cultures. This is again categorical, yes, maybe no. You have group implications. So these are distinguished from individual only attacks or insults that do not invoke power dynamics between groups. So again, you have these examples. So in the second example, you can see that it is targeting a specific group using some slur terms. So this is again categorical with two answers, no or yes. Then you have targeted group, which is a free text answer, and it provides a list of demographic or social groups which are being targeted, and the authors also have and readers also have a seed list to choose from. And finally, implied statement represents the power dynamics or stereotype that is referenced in the post. They again collect free text answers in the form of simple hearse-like patterns. So, why is this why is the implied meaning negative? So the annotators filled things like women are some adjective. So this is why what the post is trying to convey. Then you have in-group language, which aims to capture whether the author of a post may be a member of the same social demographic group that is targeted, as the speaker identity changes how a statement is perceived. So maybe I'm making a self-deprecating joke. Specifically, in-group language, words or phrases as re-established belonging to a social group can change the perceived offensiveness of a statement, such as reclaimed slurs. So again, reclaimed slurs are slurs which were earlier used to uh, target people, but now the communities have embraced those slurs and sort of made them, converted them into daily use. So the N word is one such slur. So some version of the N slur are commonly used. You must have seen them in movies and in, say, American rap and so on. Again, this has a yes, maybe no classification. Now we delve into the annotation process. So they have a crowdsourcing framework. For data selection, they draw from various sources of potentially biased online content shown in table 2. Table 2. So this table just shows examples. Uh, I won't want I wouldn't like reading them. So, but this example on Korean artist, it's offensive. Is it intentional? They say no. Is it lewd? No. Does it target a group? Yes. What's the target group? Korean folks. What's the implied statement? That they have weird names. And is it in group? So is this the some Korean people talking amongst themselves? No. So for data selection, they're using all of these data sources. So you have these four subreddits. You have these three very famous hate speech datasets. You have these hate sites, Gab, Stormfront, and some banned Reddits. And then you have the total created from all of them. So the banned subreddits include R incels and R men's rights. Since online toxicity can be relatively scarce, we start by unrating English Reddit posts, specifically three intentionally offensive subreddits and a corpus of potential microaggressions. By nature, the three offensive subreddits are very likely to have harmful implications, which is of course true because they're intended to create be offensive. Microaggressions, on the other hand, are likely to contain subtle biased implications, which is very good for a social bias frame dataset because you also need implicit uh, hatefulness. In addition, we include posts from three existing Twitter datasets annotated for toxic or abusive language, filtering out the at replies, retweets, and links. And they mainly annotate tweets released by Founder et al., they use a bootstrapping approach to sample potentially offensive tweets. They also include the tweets from Wasim and Hovi and the Davidson dataset, who collected a dataset of tweets containing racist or sexist hashtags and slurs. Finally, we include posts from known English hate communities like Stormfront and Gab, which are both documented white supremacist and neo-Nazi communities, and two English subreddits that were banned for inciting violence against women. So R incels and R men's right. Now you know what's the data source. Now let's look at the annotation design. So they design a hierarchical annotation framework to collect biased implications. A snippet is in figure 2 and The full task is in appendix figure 4. So this is figure 2. Um, this is a bit unclear, right? Maybe I'll try opening this in the PDF form itself and it wouldn't be so blurry there. Or so I hope. Yeah, it's not as blurry here. So this is a sentence. Then it tells them what source was used, and then they ask, would this be offensive? Would this be intentional? Uh, so they have some seed target groups, and then you can fill in others. You can also fill in your uh, intent information, and then you can choose some, I guess, what is being used to attack people. So this is their annotation framework. So they design a hierarchical annotation frame. Okay. For each post, workers indicate whether the post is offensive, whether the intent was to offend, and whether it contains lewd or sexual content. Only if annotators indicate potential offensiveness do they answer the group implication question. If the post targets or references a group or demographic, workers select or write which ones. Per selected group, they also need to write 2 to 4 stereotypes. Finally, workers are asked whether they think the speaker is part of the minority group or not. We collect the annotations per post and restrict the worker pool to the US and Canada. We ask workers to optionally provide coarse grained demographic information. Alright, so this is the statistics for the SBIC dataset. We'll go over this when this comes up. So the annotator demographic, you have 55% women, 42% men, less than 1% non-binary, and this is the age range. And it's racially skewed, of course. So you have 82% white, 4% Asian, 4% Hispanic, and 4% black. Annotated agreement is quite high, 82.4% pairwise agreement and a 0.45 cryptendorse alpha on average, which is substantially higher than previous work. So earlier it was 0.22. Broken down by each categorical question, workers agreed on a post being offensive at a rate of 76%, intent 75, and so on. So this is just annotated agreement. I'm not going to talk a lot about this. However, flagging potential in group hate speech has had lower agreement, likely because this is a very nuanced annotation. Because in-group information is very subjective. Uh, it's not really clear, and people might have different viewpoints. Finally, workers agreed on the exact same target of 80.2% of the time. For SBIC description, you have 150,000 structured inference tuples covering 34,000 free text group implication pairs. Just show the example inference tuples in table 1. So basically, this has some tuples from SBIC. Additionally, they show a breakdown of types of target groups in figure 3, while SBIC covers a variety of types of bias, gender-based, race-based, and so on. Culture-based bias are the most representative, which parallels the type of discrimination happening in the real world as well. They also find that dataset is predominantly written in white-aligned English, as measured by the lexical dialect detector by Blodgett et al., while less than 10% have indicators of African American English. We caution researchers to consider the potential for dialect or identity-based bias in labeling before deploying technology based on SBIC. All right. So this is the group breakdown. You can see that for the Twitter dataset, 56% was talking about gender, while for Reddit, it's more dominated by race. And for hate sites, it's equally divided between gender and race, while religion is also substantial. And this is the statistic. These are the statistics. So you have 44,000 posts, you have 1,414 unique groups, you have 32,000 implications, and then you have the post group implication, the group implication, and the skewness. So how much of it is offensive, how much of it is lewd, and so on. So social bias inference. Given a post, we establish baseline performance of models at inferring social bias frames. An ideal model should be able to both uh, So an ideal model should be able to both generate the implied power dynamic in textual form as well as classify the post offensiveness and other categorical variables. Satisfying these conditions, we use the OpenAI GPT transformer models as a basis for their experiment, given their recent success rate. Of course, everyone knows GPT is very successful. So for training, they cast the frame prediction task as a hybrid classification and language generation task. So they linearize. So if you're familiar with knowledge graphs, you can linearize your tuples, triplets, sorry. They linearize the data in a similar fashion. And at training time, the input is this entire sentence, linearized sentence. So I'm not sure if you can also call this a sentence. This is just a linearized linearized set of order tokens. So you have separators, you have initially the words, then you have uh, some lead offensive intent and group separators, and you have explanations and so on. So STR is the start token, W12N is the sequence token, GI is the token representing the group, and WSI is the token representing the implied statement. And then they are add two task specific vocabulary item for each of the five classification tasks, each representing the negative and positive values of the class. So for offensiveness, you have either of y and of n, because you have only two cases. The model relies on a stack of transformer blocks of having multi-headed attention and fully connected layers. So these encode the input tokens, and since GPT is a forward-only language model, the attention is only computed over preceding tokens. So this is not something like BILSTMs. And at the last layer, the model projects the embedding into the vocabulary size vector, which is turned into a probability distribution using softmax. So this is just how GPT works. Then they minimize the cross entropy loss in the of the full contextual probability of the correct uh, token in a final linearized frame objective. So this is your cross entropy loss. During training, no loss is incurred for lower level variables with no values, that is variables that cannot take values due to earlier variable values. So there is no target group for post marked as non-offensive. So for them, there is no loss. In their experiments, they use pre-trained GPT and GPT-2. So they've called them SBF GPT-1 and SBF GPT-2. While the architecture values are similar, GPT was trained on large corpus of fiction books, while GPT-2 was trained on 40 gigs of English web text. For inference, we frame our generation task as a conditional language generation task. Conditioned on the post, we generate tokens one by one, either by greedily selecting or by sampling from the next word distribution and appending the selected tokens. And then they stop when the end token is generated, at which point our entire frame is predicted. For greedy decoding, we only generate one frame once, but for sampling, we repeat the generation procedure to yield 10 candidate frame prediction and choose the highest scoring one. In contrast to training, where all inputs are consistent with a frame structure, at test time the model can sometimes predict combination of variables that are inconsistent with the constraints of the frame. So like it is predicting a post to be inoffensive but still predicting it to be offensive to a group. To mitigate this issue, we also experiment with a constraint decoding algorithm denoted const that considers various global assignments of variables. Specifically, after greedily decoding, we recompute the probabilities of each of the categorical variables and search for the most probable assignment given the generated text candidate and various probabilities. This can allow variables to be assigned an alternative value that is more globally optimal. All right. So this is just a constraint in the decoding for cases like uh, where the model would first say that it's not offensive, but then create for other finer grain labels, it would say it's offensive. For evaluation, they use F1 precision recall for the classification, and following previous generative models, they use Blue2 and Rogel to capture word overlap, and they also use a word mover distance. For training, again, they have a 75 12.5 12.5 split, and they combine the categorical variables by averaging their binarized values and rebinarizing using a zero point 0.5 threshold. So beyond zero point 0.5 is class A, below zero point 0.5 is class B, and then they compare the generated inferences to all target groups and implied statements. As experiments are carried out using Hugging Face transformers, the hyperparameters and report performance for the best of our models. They train on batch size of 4, learning rate of 5, E negative 6, and 10, and 1 E negative 5 for GPT-2. Both will linear warm up and consider training for 1, 2, or 5 epochs. The results are in table 4 or 5. So for table 4, these are the results for GPT, GPT-2, and then the different configurations. So GDY is just argmax, SMP is sampling, and this is for GPT-1 and GPT-2, and then for only for GPT-2 they're doing the sampling. So some models did not predict the positive class. Their performance is denoted by a not applicable type, so just a hyphen. And then they bold the F1 scores of the best performing model. So GPT 2 works best with sampling for offensive, but GPT-2 with picking the best token works best for intent and so on. And then here they also have the constrained decoding method in some cases, and they compare the blue scores over the target groups and also the implied statements. For classification shown in table 7, models perform well on higher level variables because of course they're easier tasks, and they also hypothesize that correctly predicting lewdness might require more lexical matching. Whether the group is targeted in slightly less easy for models to predict, and whether the languages in group is even more challenging because of course it's even difficult for humans. This highly skewed category poses a challenge for all models, likely due to subtlety of the task and the lack of positive instances. So SBF GPT-2 GDY is the only model that predicts positive values for in-group language, for which it benefits from the constrained decoding with 1.9% improvement in F1 score. Then these are some examples. For generation, when evaluating a model on generation tasks, they find no one model outperforms others across all metrics. However, models do well at generating the target groups, likely because of the more limited generation space. Conversely, for implied statement, the generation space is much larger, the model performance is worse. Similar to classification tasks, SBF-GPT-2 GDY shows a slight increase in Rougeal score while using constrained decoding, but that leads to a drop in blue score. So anytime you constrain the decoding, you have some sort of a trade-off in n-gram level scores, especially because these are just not using say synonym level comparisons but naively matching n-grams. So for error analysis, since small differences in automated evaluation metrics only weakly correlate with human judgment, they perform error analysis and will look at some samples. Overall, the model seems to struggle with generating textual implications that are relevant to the post. Instead, they generate very generic stereotypes about the demographic group. So, like an example be these are just very generic stereotypes which are being generated. The model generates the correct stereotypes when there is high lexical overlap with the post. So it is not really able to infer or perform inferential stuff. It's able to find some keywords or key concepts in the post and use those. This is in line with previous study which shows that large language models rely on correlational patterns in data. For so some related work, you have bias and toxicity detection. So these are all discussions about datasets and models. You have perspective API, which is you open source mod, not a open source, which is a API based model which you can use to get a lot of labels, and it is rate limited and paid after some time, I guess. So they mentioned that this work by Wulshins et al. And the perspective API, they use a set of binary labels to annotate Wikipedia comments for several toxicity-related categories. So Zampieri et al. Have the older dataset, and you have Oshidome et al., who created a multilingual dataset. Fa- In comparison, social bias frames not only captures toxicity and hierarchical information, but also free text implications. Similar in the spirit of the paper, recent work has tackled more subtle things such as microaggression and or condescension. These types of biases are in line with biases covered by social biases, but more narrowly scoped. So these are much broader. For inference and social dynamics, you have various works which discuss this. So you have separate work by the same authors, and they where they try to uh, capture the power dynamics in conversation between entities or in a narrative text. Then you have recent work in common sense inference, which has focused on mental state of participants of a situation. And in contrast to reasoning about particular individual, this work focuses on biased implications of social and demographic groups as a whole, on them as a whole. Finally, you have the ethical considerations and the acknowledgement, which I'm not really these things. I guess you can read them on your own. So their conclusion is that they've created a new data set which provides more information about the task, and they've also shown some baseline studies on the same. I think I hope you like this video, and if I'm missing something or you want to correct me, do not hesitate to do so in the comments. There is an appendix, I believe, which shows some results. Yeah, so these are just showing some results. So thank you guys for tuning in. Hope to see you again next time as well.